Hello, friend. Welcome to Science for Sleep. Whether you are returning tonight or arriving here for the very first time, this is a quiet place to slow down, learn something gentle, and let the weight of the day begin to fade. Tonight, we are going to spend time with one of the most familiar animals in human history, the horse. Picture one standing in a quiet field at dusk. Its body is still, but not asleep. One ear turns toward a distant sound. The other points softly behind it. Its tail moves once through the air. Its chest rises and falls with slow, steady breaths. A horse can look peaceful from far away, almost like part of the landscape. But inside that calm shape is one of the longest and most surprising stories in the animal world. The modern horse belongs to a family called Equidae. That family also includes zebras and asses. Today, horses are large, one-toed grazing animals, built for open ground, long movement, and careful attention. But they did not begin that way. The first members of the horse family appeared in North America around 55 million years ago. They were small forest animals, closer in size to a fox or a small dog than to the tall horses we know today. They moved through warm, ancient forests on several toes, eating soft leaves and fruit. There were no saddles, no barns, no roads, no riders crossing open plains, only a small animal stepping through shade long before humans existed. If you enjoy these quiet journeys, you're welcome to subscribe. And if it feels natural, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. The quiet continues here, just as it is. One of the strangest things about horses is hidden in the hoof. A horse looks like it is standing on a hard, simple foot. But that hoof is really built around one enlarged middle toe. Long ago, early horse relatives had several toes touching the ground. Over millions of years, as some horse ancestors moved into more open land, the side toes became smaller. The middle toe became stronger, and the hoof became the strong, rounded structure that carries the horse's weight today. So when a horse walks across a pasture or trots along a fence line, it is moving on a body shaped by deep time. Every step holds a trace of vanished toes. Every quiet hoofprint carries a memory of ancient forests and changing land. The horse's teeth tell another part of the story. Modern horses graze on grass for many hours each day. Grass may look soft, but it is tough food. It contains hard particles of silica, and it often carries tiny grains of soil that wear teeth down over time. Because of that, horses evolve tall teeth that keep pushing upward as the chewing surface wears away. Their mouths became grinding tools for a grassland world. Their legs became longer. Their eyes watched wide spaces. Their bodies became built for motion, distance, and escape. And yet, the story took another strange turn. Although horses evolved in North America, they disappeared from North America near the end of the last ice age, around 10,000 years ago. For thousands of years, the continent where horses began had no horses left. The animals survived elsewhere, across Eurasia, where their history would eventually become tied to people, herds, roads, farms, armies, cities, and quiet human hands resting on warm necks. Much later, horses returned to the Americas with Europeans. By then, they were no longer only wild animals shaped by grass and weather. They had become part of human life. They carried people across long distances. They pulled wagons and plows. They moved messages, goods, families, and entire cultures. But all of that came later. For now, it is enough to picture the horse in the field. Large, breathing, watchful, and calm. A living animal with ancient North America in its bones, grassland survival in its teeth, and one long toe hidden inside each hoof. Before horses carried human history, they first had to become horses. And that story begins in a world where they looked almost nothing like the animals standing quietly beside us now. Far behind the quiet pasture, the land begins to change. The fence fades. The barn fades. The open field softens into a much older North America, around 55 million years ago. This was the Eocene epoch, a warm chapter of Earth's history that lasted from about 56 million to 34 million years ago. In many places, forests spread across the land in thick green layers. The air was warmer than it is today. Palms and broadleaf trees grew much farther north than they do now. Small mammals moved through shadows beneath the branches, stepping over damp leaves, roots, fallen fruit, and soft soil. Among them was one of the earliest members of the horse family. It would have looked surprising beside the animal we know. Older books often call it Eohippus, meaning dawn horse. Scientists have also used the name Hyracotherium for closely related early forms. Either way, this early horse relative was small, often compared to a fox or a small dog. It may have stood only about 16 to 20 inches high at the shoulder. A modern horse can stand 5 feet or more at the shoulder, so the difference is easy to picture. The great body, long neck, and strong chest of the modern horse had not yet appeared. This little animal moved close to the forest floor. Its back was slightly arched. Its legs were shorter. Its head was smaller. Its body was made for slipping through plants, turning between trunks and stepping across uneven ground. The feet were one of the clearest differences. Instead of one strong hoof on each leg, this early horse relative had several toes. The front feet had 4 functional toes. The hind feet had 3. Those toes spread its weight across softer forest ground, where a narrow hoof would have been less useful. On damp soil, leaf litter, and shaded earth, a wider foot helped the animal stay balanced. Its body matched the world around it. The mouth tells the same quiet story. This early horse relative had low crown teeth. That means the chewing part of each tooth was not especially tall. Low crown teeth work well for softer food, such as leaves, tender shoots, and fruit. They are less suited for a life spent grinding tough grass full of grit. At this point in the horse story, grasslands had not yet become the main stage. The animal was a browser. A browser feeds from bushes, trees, and soft plants, rather than grazing close to the ground like a modern horse. So the early horse did not need the deep grinding teeth of a grassland grazer. It needed a mouth for the forest, a small head reaching toward leaves, a jaw working through softer plant tissue. teeth shaped for a shaded world where food grew at different heights. Its size also made sense. A small body needs less food than a large one. It can hide more easily under cover. It can move through dense plants where a larger animal would struggle. In a forest filled with branches, shadows, and narrow spaces, being small could be useful. Speed across open land mattered less here than careful movement through cover. The early horse family was already alive, already adapting, already beginning its long path. Yet the familiar signs of the modern horse were still only hints. There was no single hoof striking dry ground. There was no long mane blowing across an open plain. There was no large herd moving over miles of grass. There was a small animal in a warm forest, carrying the first pieces of a much larger future. That contrast is part of what makes the horse story so strange and beautiful. The animal that would someday pull carts, carry riders, cross continents, and become a symbol of freedom, began as a quiet leaf eater under trees. Its body was not unfinished. It was suited to its own world. The small size, the many toes, the low teeth, and the browsing mouth all belonged to that ancient forest. Over time, the ground beneath the horse family would become drier, wider, and more exposed. The shade would thin in many places. The food would change. The dangers would become easier to see from far away and harder to escape without speed. As the land opened, this small forest animal faced a very different kind of world. Across that ancient North American land, the forest did not vanish all at once. It thinned slowly over millions of years. Warm, leafy places still remained, but in many regions the spaces between trees grew wider. The climate shifted. Rainfall patterns changed. Some areas became drier. Open woodland, brushland, and early grassland began spreading across parts of the continent. This long change unfolded through the Cenozoic era, the age of mammals, which began about 66 million years ago and continues today. For the horse family, the ground itself was becoming a new kind of challenge. A small animal that once moved under thick cover now faced longer distances between shelter. Predators could be seen from farther away. Food was lower to the ground. The open land gave fewer places to hide, so movement became more important. A body that could travel farther, react sooner, and run more efficiently had an advantage. This is how natural selection works. When some animals are born with traits that help them survive and have young, those traits can become more common over many generations. No animal chooses the change. The environment quietly rewards certain bodies more than others. For early horses, the reward began to favor longer legs, stronger feet, and teeth that could handle rougher food. Grass became one of the great pressures in this story. From a distance, grass can look soft and harmless. A field of grass moves gently in the wind, bending in waves under the open sky. But for an animal's mouth, grass is difficult food. Many grasses contain tiny hard particles called silica. Silica is the same basic mineral found in quartz and sand. Grass also grows close to the soil, so each bite can carry fine dust and grit. Those hard particles scrape against teeth again and again. Over a lifetime of chewing, they can wear a tooth down. A browser eating soft leaves in a forest can live with lower teeth. A grazer eating grass for hours each day needs a stronger dental system. So in some horse lineages, the teeth became taller. Scientists call these high-crowned teeth hypsodont teeth. The word simply means the tooth has a tall crown, giving it more material to wear through. In modern horses, the teeth keep slowly pushing upward from the jaw as the chewing surface wears down. That slow movement helps the horse keep grinding grass year after year. The legs were changing too. As horse relatives moved through more open habitats, longer limbs help them cover ground with fewer steps. A longer stride saves energy during travel. It also helps an animal move away quickly when danger appears. In a forest, a small body can turn between trunks and disappear into shadow. On open ground, the body must answer danger in a different way. It must notice early. It must move with force. It must keep going long enough to reach safety. The world was asking the horse family to become more open country animals. Over time, different horse relatives took different paths. Some stayed smaller, some became larger, some kept more of the older forest pattern. Others moved toward the shape we recognize more easily today. Evolution is full of branches like this. Many forms appear, live for a while, and disappear. The modern horse is only one surviving line from a much larger family tree. Still, the direction is clear in the fossils. Bodies grew larger in many horse groups. Legs lengthened. Teeth became better suited for grazing. Feet became more focused on the central toe. The animal was being drawn outward, away from the close forest floor and toward wider land. A horse's body began to carry the shape of distance. The field, the horizon, the need to run, the need to graze, all pressed gently across countless generations. The change was slow enough that no single animal would have noticed it. Yet across millions of years, the family was becoming something new. The first clear sign of that change sits beneath the body, where the old spread of toes slowly narrowed into a stronger and stranger kind of foot. Look closely at an early horse stepping through soft Eocene ground. Its feet do not strike the earth like the round hooves of a modern horse. They spread, they press. They settle into damp soil with several small toes touching the surface. On the front feet, early horse relatives such as Hyracotherium carried 4 working toes. On the hind feet, they carried 3. Each toe ended in a small hoof-like nail, giving the animal a wider base as it moved through forest floors, leaf litter, and uneven ground. That kind of foot made sense in a shaded world. Soft soil can shift under weight. Roots can lift the ground into small ridges. Fallen branches can make each step slightly different from the one before it. A small animal moving through that kind of place benefits from a foot that can spread its weight. The toes gave balance. They gave contact. They helped the body adjust to a forest floor that was never perfectly flat. As the horse family moved through millions of years of change, the ground beneath it became firmer and more open in many places. The central toe began to matter more. In later horse relatives, the middle toe carried more of the body's weight, while the side toes became less important. One example is Mesohippus, a horse relative from around 37 to 32 million years ago. It had 3 toes on each foot, and the middle toe was already larger than the toes beside it. The animal was still far from a modern horse, but the direction of change was visible. The foot was beginning to narrow around a stronger center. Later, in horses such as Merychippus, which lived around 17 to 11 million years ago, the middle toe became even more dominant. The side toes were still present, yet the animal's weight was carried mainly through the enlarged central toe. Over time, those side toes became smaller. They lifted farther from the ground. They lost their old role in movement. The horse family was gradually building a limb that worked more like a springing column than a spreading foot. This change helped with forward motion. A narrower foot can swing more efficiently at the end of a long leg. Less weight near the ground can make each stride easier to repeat. On open land, where the animal moves mostly forward across firmer surfaces, that matters. The modern horse belongs to a group of animals called unguligrades. That word means they walk on the tips of their digits. A digit is a finger or toe. So a horse is, in a very real sense, standing on the tip of one enlarged toe on each leg. The hoof is the hard outer covering around that toe. Inside it are bones, joints, blood vessels, nerves, and soft tissues that help carry the animal's weight. The main bone inside the hoof is often called the coffin bone. Its shape helps support the hoof capsule, the tough outer wall that meets the ground. Each quiet step depends on this hidden structure. When a horse walks across a paddock, the hoof wall touches first. The inner tissues absorb force. The limb above it moves like a long, controlled lever. Even though the side toes disappeared from the outside, traces of them remain. Modern horses have thin bones along the sides of the lower leg, called splint bones. These are linked to the reduced side toes of ancient horse relatives. They no longer touch the ground as full toes. They sit quietly inside the leg as reminders of an older design. Evolution often works this way. It reshapes what is already there. It leaves pieces behind. It turns an ancient structure toward a new use, while faint signs of the past remain inside the body. The hoof, then, is more than a simple hard foot. It is an old toe strengthened into a weight-bearing point. It carries the horse over grass, dirt, stone, and sand. It holds the memory of forest ancestors that stepped on several toes in soft ground. As the foot narrowed and the middle toe became the center of movement, the horse gained a better tool for open country. The step became cleaner. The stride became longer. The body could move across wider spaces with more ease. Once the horse stood on this narrow, powerful point of contact, the rest of the body began to stretch into a machine for distance. Above the hoof, the horse's body keeps building the same idea. The force of each step travels upward through the lower leg, into the knee or hock, through the long bones and into the shoulder and hip. A horse's front knee is called the carpus. Its hind hock is a joint similar to the human ankle. These joints fold and open as the animal walks, trots, canters, or gallops, turning the hard push from the ground into smooth forward motion. The long leg is one of the easiest changes to see. A modern horse has much longer limbs than its small forest ancestors. Long limbs increase stride length, which means the animal covers more ground with each step. For an animal living in open country, that can save energy over distance. A horse does not need to take as many short steps to move across a wide space. The body reaches forward, gathers itself, and flows onward again. The lower leg has another important feature. Below the knee on the front leg and below the hock on the hind leg, there is very little bulky muscle. Much of the large muscle sits higher up, closer to the chest, shoulder, hip, and thigh. Lower down, the leg is filled more with bone, tendons, and ligaments. A tendon is a strong cord of tissue that connects muscle to bone. A ligament is a strong band that helps hold bones and joints together. This lighter lower leg matters because the end of the limb has to swing back and forth many times. A heavy lower leg would take more energy to move. A lighter one can repeat the motion more easily. The tendons also help the horse move like a spring. When the hoof meets the ground, parts of the limb stretch slightly under the animal's weight. Energy is stored for a brief moment in the tendons and ligaments. Then that energy helps push the body forward again. One important structure is the suspensory ligament, which helps support the fetlock, the joint just above the hoof. When a horse trots, the fetlock can sink toward the ground and then rise again, quietly storing and releasing force. This spring-like system helps explain why a horse can travel with such smooth power. Speed is part of the story, yet endurance matters too. Horses have large lungs that pull in air through wide nasal passages. They are obligate nasal breathers, which means they normally breathe through the nose rather than the mouth. During a gallop, the movement of the body is tied closely to breathing. As the horse stretches forward and the organs shift inside the body, air moves in and out in rhythm with the stride. At high speed, a horse often takes one breath for each stride. The heart must keep pace with that work. An adult horse's heart weighs several kilograms, and in a fit horse, it can move large amounts of blood to working muscles. That blood carries oxygen, which muscles need to keep producing energy. The limbs, lungs, and heart all belong to the same moving system. A horse also carries the nervous system of a prey animal. Its ancestors survived by noticing danger early and moving quickly. Modern horses still startle at sudden motion, sharp sounds, or unfamiliar objects. A plastic bag shifting in the wind can matter to a horse because its body is tuned to react before danger gets close. This does not make the horse foolish. It shows how deeply survival shaped its attention. In open land, a fast response could mean another day of grazing with the herd. The joints add to this design. A horse's limbs are especially good at moving forward and backward. They are less suited to twisting sharply than the limbs of animals built for climbing, grabbing, or sudden sideways turns. The body favors a clear direction of travel. Hoof, tendon, bone, muscle, lung, heart, and attention all work together as the horse crosses ground. The small forest browser has become something longer, taller, and more open to distance. Yet movement always depends on fuel. A body made for travel needs a way to keep feeding itself across wide land, and the answer is written in the horse's mouth. The head lowers toward the ground. The long neck stretches forward. The lips move carefully through the stems, choosing mouthfuls close to the soil. A grazing horse can spend much of the day this way, slowly walking, stopping, chewing, and moving again. From a distance, grass seems gentle. It bends under wind. It shines with dew in the morning. It covers fields in a soft green layer. Inside the horse's mouth, grass is much harder than it looks. Many grasses contain tiny particles of silica. Silica is a hard mineral found in sand and quartz. As grass grows, these small particles become part of the plant tissue. A horse also pulls grass from near the ground, where dust and fine grit can cling to the stems. With every bite, those hard grains rub against the teeth. Over months and years, that rubbing matters. A tooth that works well for soft leaves would wear down too quickly on a lifetime of grass. This is why the horse's teeth changed along with the land. Modern horses have high crown teeth. The scientific word is hypsodont. It simply means that the visible crown of the tooth is tall, with a long reserve of tooth material below the gum line. As the chewing surface wears away, more tooth slowly moves upward from the jaw. This process is often called eruption. It does not mean the tooth grows endlessly like a fingernail. It means the tooth has a deep store of material that gradually comes into use as the top is ground down. A young adult horse may have teeth with many years of hidden height still below the gum. By old age, much of that reserve can be used up. This is one reason elderly horses can have trouble keeping weight on. The grinding machine in the mouth has simply done its work for a long time. The way a horse chews also matters. A horse does not only bite straight up and down. Its jaw moves partly side to side, so the upper and lower cheek teeth grind plant fibers against each other. The chewing surfaces develop ridges of enamel and softer material. Enamel is the hard outer substance of a tooth. As different parts wear at different speeds, the surface becomes useful for crushing and shredding grass. The food is broken into smaller pieces before it travels down the throat and into the stomach. Yet the horse's main plant-breaking work happens farther along. Horses are hindgut fermenters. That means much of their digestion of plant fiber happens in the back part of the digestive system, especially in the cecum and large intestine. The cecum is a large pouch near the beginning of the large intestine. In an adult horse, it can hold many gallons of material. Inside it live huge numbers of microbes. Microbes are tiny living things, including bacteria, that help break down cellulose. Cellulose is the tough substance that gives plant cell walls their structure. A horse cannot break cellulose apart by itself very well. The microbes do much of that quiet work. As they ferment the fiber, they produce fatty acids that the horse can absorb and use for energy. This is how a field of grass becomes motion, warmth, and muscle. Cattle handle grass in a different way. They are ruminants with a multi-chambered stomach. They swallow food, bring it back up as cud, chew it again, and send it through the stomach system for deeper processing. Horses do not chew cud. Their stomach is relatively small for an animal of their size. Food moves through more quickly, and fiber is processed later in the hindgut. This system allows horses to graze steadily across wide land. It also means they are built for frequent eating rather than long, empty stretches. In a natural setting, a horse may graze for many hours in a day, taking in small amounts again and again. The mouth, teeth, jaw, cecum, and microbes all belong to the same grassland design. The running body needs fuel. The grazing mouth gathers it. The hidden life inside the gut helps turn rough stems into usable energy. Even a quiet horse standing with its head down in a pasture is part of an old evolutionary answer. The grass wears the teeth. The teeth meet the grass. The gut receives what the mouth has prepared. Across open land, survival depends on more than feeding well, because a grazing animal with its head lowered must also stay aware of the world around it. That awareness becomes stronger when it is shared across many bodies in the herd. In a grazing group, attention moves quietly from one body to another. A few horses lower their heads to feed. One horse pauses with grass still between its lips. A young one shifts closer to its mother. Farther away, an older mare lifts her head and turns one ear toward a faint sound. Nothing dramatic has happened. The field is still calm. Yet the herd has already begun to read the world together. Horses are social herd animals, and for a prey species, that social life is part of survival. A single horse with its head down can miss something. Several horses spread across a field create a wider circle of awareness. While one animal grazes, another may be looking outward. While one rests, another may notice movement in the distance. Safety is shared through the group. The horse's eyes help make this possible. They sit on the sides of the head, giving the animal a very wide field of view. A horse can see much of what is happening around its body without turning its head fully. This is useful in open country, where danger may appear from the side or behind. There are still blind spots. A horse has a blind area directly in front of its face, close to the nose. It also has a blind area directly behind the body. That is one reason sudden movement from behind can startle a horse so quickly. Its body is built to react before danger gets too close. The ears add another layer of information. A horse's ears can move independently, so one ear may point forward while the other listens behind. Each ear can rotate toward small sounds, a branch moving, another horse stepping, a distant animal crossing dry grass. People who spend time around horses often learn to watch the ears first. Pinned ears can signal irritation. Forward ears can signal interest. One relaxed ear drifting sideways may show that the horse is calm, but still listening. These movements are small, yet within a herd they matter. Posture carries messages too. A raised head can spread alertness through nearby animals. A tense neck can change the mood of a group. A slow blink, a lowered head, or a loose hind leg can signal calm. Horses also pay attention to spacing. Some stand close to trusted companions. Others keep a little more distance. Within stable groups, familiar horses often form preferred bonds. They may graze near one another, rest near one another, or seek each other after being separated. Mutual grooming is one of the clearest signs of these bonds. Two horses may stand side by side, each using teeth and lips to scratch the other's neck, withers or back. The withers are the high ridge between the shoulder blades. This kind of grooming can remove dirt and insects, but it also helps maintain social connection. The slow pressure of teeth along the coat can lower tension between familiar animals. The herd becomes more than a crowd. It becomes a living pattern of attention, memory, and comfort. Even sleep is shaped by this shared awareness. Horses can doze while standing, using a special arrangement of tendons and ligaments, often called the stay apparatus. This system helps lock parts of the legs so the horse can rest lightly without collapsing. Standing rest is useful for a prey animal that may need to move quickly. Deeper sleep is different. For the deepest stages of sleep, including REM sleep, a horse needs to lie down. REM sleep is a stage when the body becomes very relaxed and dreaming is more likely. A horse cannot safely stay in that state while standing. In a calm herd, some animals may lie down while others remain upright nearby. The group makes rest safer. This social awareness did not appear for human benefit. It grew from open land, predators, grazing, and the need to survive with other horses. Still, it would later become one of the reasons humans could form such close working relationships with them. A horse that reads tiny changes in ears, posture, pressure, and movement can also learn to read the body of a person standing beside it. Long before that partnership began, horse herds were already moving through ancient landscapes as watchful communities. Their bodies had changed. Their teeth had changed. Their feet had changed. Now their group life carried them across wider ground and over deep time. Those moving herds would travel far beyond their birthplace. Those moving herds eventually turned the horse story into a story of continents. For most of their deep history, horses belonged to North America. The small forest forms, the three-toed runners, the grazing horses with taller teeth, and many extinct branches of the horse family all developed across this continent over tens of millions of years. Fossils from places such as Wyoming, Nebraska, South Dakota, and Oregon preserve pieces of that long record. In some ancient rock layers, scientists have found teeth, skulls, leg bones, and foot bones from many different horse relatives. Together, they show a family that changed again and again as forests, plains, rivers, and climates shifted around it. The horse family spread outward when the land allowed it. During cooler periods of Earth's history, large amounts of water became locked inside glaciers. When so much water was held as ice, sea levels dropped. At times during the Ice Age, sea level could fall by more than 300 feet. That exposed land in places that are covered by ocean today. One of the most important routes was Beringia, the broad land region that connected Alaska and Siberia. Today, the Bering Strait is a cold stretch of water between North America and Asia. During lower sea levels, it became a wide bridge of tundra, grass, shrubs, and open ground. Animals could move across it over many generations. Mammoths crossed there. Bison crossed there. Early humans crossed there too. Horse populations also moved between North America and Eurasia through this northern route. This movement did not happen as one dramatic crossing. It unfolded slowly as herds followed food, seasons, and habitable land. Some horse lineages entered Eurasia and continued their history there. Across the open regions of Asia and Europe, they found new landscapes, new predators, and new pressures. The horse, born in North American deep time, became a wider northern animal, spread across great stretches of the world. Then the story turned in a strange direction. Near the end of the last ice age, around 10,000 years ago, horses disappeared from North America. By that time, large ice age animals across the continent were also declining or vanishing. mammoths, mastodons, giant ground sloths, American camels, and saber-toothed cats all faded from the landscape. The exact cause is still studied, because several pressures arrived close together. The climate warmed after the last glacial maximum. Ice sheets retreated. Plant communities shifted. Grasslands, woodlands, wetlands, and seasonal patterns changed in different regions. Animals adapted to cold, open ice age environments, faced a world that was being rearranged. Humans were also present in North America by then. People hunted large animals, used stone tools, moved through changing landscapes, and may have added pressure to already stressed populations. For horses, climate change, vegetation shifts, and hunting may have worked together. The disappearance was local, because horses survived in Eurasia. The birthplace lost them, while other continents carried the family forward. For thousands of years after that, no horses grazed the plains of North America. The land that had shaped their teeth, feet, limbs, and herd life became a horseless continent. Grass still moved in the wind. Predators still crossed valleys and rivers. Human groups lived, hunted, traveled, and built cultures across the land. The animal that had evolved there was absent. Horses returned much later through human history. European ships carried domestic horses across the Atlantic. Spanish horses arrived in the Caribbean in the late 1400s, and horses reached the mainland of North America in the 1500s. Some were ridden by soldiers and settlers. Some escaped. Some were traded. Over time, horse populations spread again across parts of the continent, especially through indigenous trade networks and the open grasslands of the Great Plains. Their return changed travel, hunting, warfare, trade, and daily life for many peoples. It also created a deep historical twist. The horse came back to the continent where its family had begun, carrying a new relationship with humans that had formed elsewhere. Long before that return, and long before riding, saddles, wagons, or reins, people had already noticed horses. They watched them from a distance, followed their movements, hunted them for survival, and painted their shapes on stone walls deep inside caves. Inside those Ice Age caves, horses appear with a kind of quiet importance. They are painted with curved necks, heavy bodies, lifted heads, and dark outlines made from minerals, charcoal, and earth pigments. The people who made these images lived in a colder world than ours. Much of northern Europe was shaped by ice sheets, open steppe, and wide grasslands where large animals moved in herds. Mammoths, reindeer, bison, aurochs, woolly rhinoceroses, and horses all shared parts of that ancient landscape. For Ice Age humans, horses were living animals first. They moved across valleys and plains. They left tracks in mud and snow. They gathered in groups where grass and water were available. People watched them closely because watching animals was part of staying alive. A horse herd could mean food, hides, tools, and material for shelter. In parts of Ice Age Eurasia, horse bones found at archaeological sites show that people hunted and processed them. Cut marks on bones can show where stone tools removed meat. Broken bones can show where marrow was taken from the inside. Marrow is the rich fatty tissue inside certain bones, and for people living in cold environments, fat, was extremely valuable. Horsehide could be used for coverings, clothing, or straps. Sinew, the strong connective tissue from muscles and tendons, could be used as cordage. Bone could be shaped into tools. This was the earliest practical relationship between humans and horses. It was based on survival, observation, and skill. A horse was powerful, fast, and difficult to approach. A human group had to understand movement, season, terrain, and herd behavior to hunt one successfully. That kind of knowledge came from long attention. It came from knowing where animals fed, how they reacted when they gathered, and how they moved through open land. The cave walls show another layer of meaning. At Chauvet Cave in southern France, some animal paintings are more than 30,000 years old. Among them are horses drawn with careful lines and overlapping heads, as if several animals are moving together. At Lascaux Cave in southwestern France, made around 17,000 to 20,000 years ago, horses appear again among the great painted animals. The walls there include large figures of horses, bulls, deer, and other creatures, arranged in chambers far from daylight. These were not quick marks scratched beside a campsite. Some paintings were placed deep underground, where people needed lamps made from animal fat to see the stone. The choice to paint horses in those spaces tells us that they mattered beyond the moment of hunting. The images may have carried memory, teaching, ritual, or story. No one can know every meaning the artist intended, but the care in the lines is still clear. A horse's body had to be known well to be drawn that way. The curve of the belly, the weight of the head, the short upright mane, the line of the back. The painter was not inventing a horse from nothing. The painter was remembering an animal seen many times in the world outside. This makes the early human-horse relationship more complex. People used horses for food and materials. They also gave horses attention in art. They followed them across real landscapes and carried their shapes into dark stone rooms. The horse had not yet become a partner in work. No reins guided it. No rider sat on its back. No wooden cart followed behind it. Still, it already lived in human memory. That matters because domestication begins long before full control. It begins with noticing. It begins when one species learns the habits of another so closely that the distance between them slowly changes. For thousands of years, humans looked at horses as animals of movement, danger, strength, and value. Then, in the grasslands of Eurasia, that distance began to narrow in a new way. The first signs are quiet and practical. Horse bones gathered near settlements, traces on teeth, possible enclosures in the soil, and residues of mare's milk absorbed into ancient pottery. Those traces lead east, out onto the open steppe of northern Kazakhstan. Around 3,500 BCE, about 5,500 years ago, people of the Botai culture were living in settlements where horses appear again and again in the archaeological record. The steppe around them was wide and grassy. Winters could be cold. Summers could be dry. Across that open land, horses were one of the most important animals in sight. At Botai sites, archaeologists have found very large numbers of horse bones. In some places, horse remains make up most of the animal bones recovered. That alone does not prove domestication. because people had hunted horses long before this. Yet the pattern is unusual. The bones are concentrated around settlements, not scattered across distant hunting grounds. They suggest that people were living very closely with horses, returning to them often, and building daily life around them in some way. Researchers have also looked at the shape of Botai settlements. Some traces in the ground have been interpreted as possible enclosures, places where animals may have been held. A corral is a fenced or enclosed area used to keep animals in one place. Wooden fences from 5,500 years ago do not usually survive in the soil, so archaeologists search for indirect signs, such as post holes, packed surfaces, or patterns in how remains are arranged. The evidence is delicate, yet it points toward a relationship that was more controlled than ordinary hunting. The pottery gives another clue. Tiny fats can soak into clay vessels and remain there for thousands of years. When scientists test those ancient residues, they can sometimes identify the chemical signature of milk. At Botai sites, some pottery has produced residues interpreted as mare's milk. A mare is a female horse. Milking a mare requires repeated contact with living horses. It also suggests people were not only taking animals after death, they were receiving food from animals that were still alive. On the steppe, mare's milk could be turned into a fermented drink. In parts of Central Asia today, fermented mare's milk is known as kumis. That modern tradition does not prove exactly what Botai people drank, though it helps show why mare's milk would have been useful in a horse-centered way of life. Horse teeth add another piece to the puzzle. Some researchers have studied wear marks on Botai horse teeth and suggested that they may show contact with bits. A bit is a piece placed in a horse's mouth and attached to reins, helping a person guide the animal. When a bit rubs against teeth over time, it can leave certain kinds of wear. This evidence has been debated because teeth can be damaged in more than one way, and ancient marks are difficult to read with certainty. Still, the discussion itself matters. It shows how hard it is to identify the first moment when a horse became managed, ridden, milked, bred, or trained. Domestication is not a single object buried in the ground. It is a slow change in behavior, breeding, movement, and trust. The Botai story became even more interesting when ancient DNA entered the picture. DNA is the inherited code inside living things, and small pieces of it can sometimes survive in old bones. By comparing DNA from ancient horses with DNA from living horses, scientists can trace family relationships across time. That work showed that Botai horses were closely connected to Przewalski's horses. Przewalski's horses are the stocky, wild-looking horses of Central Asia with upright manes and sandy brown coats. For a long time, they were often described as the last truly wild horses. The Botai connection made that story more complicated. It suggested that Przewalski's horses may descend from horses once managed by humans, or from a population closely linked to them. At the same time, Botai horses do not seem to be the main ancestors of most modern domestic horses. So Botai remains one of the earliest strong windows into horse management, while the horse lineage that later spread through much of the human world appears to have come from another place. The path narrows again on the western Eurasian steppe, where a different population of horses began moving outward with remarkable speed. Farther west, the steppe stretches between great rivers and open sky. The lower Volga and Don rivers flow through a broad region of grassland north of the Black Sea and the Caspian Sea. Around this landscape, another horse story began to sharpen. For a long time, archaeologists had bones, tools, settlements, and pottery to study. Then, ancient DNA gave the story a new kind of map. DNA is the inherited code carried inside living things. Most of it disappears after death, broken down by water, heat, time, and microbes. But under the right conditions, tiny fragments can survive inside old bones and teeth. Scientists can carefully extract those fragments, read parts of the genetic code, and compare one ancient animal to another. With horses, this changed the whole picture. In one large ancient DNA project, researchers analyzed 273 ancient horse genomes. A genome is the full set of genetic instructions inside an animal. Each genome works a little like a family record. It can show which animals were closely related, which populations mixed, and which lineages spread into new places. When the ancient horse genomes were arranged by age and location, a pattern appeared. The horses linked to the main modern domestic lineage were not centered at Botai. They pointed instead toward the western Eurasian steppe, especially the lower Volga-Don region. This does not make Botai unimportant. Botai still shows that people were managing horses very early. It gives us bones, pottery, and a close look at one ancient way of living with horses. Yet the horses that later filled so much of the human world came mostly from a different population. Around 2200 BCE, about 4,200 years ago, that western steppe lineage began spreading quickly. Its genetic signature appears across a wider and wider area. Older local horse populations were gradually replaced or absorbed. In simple terms, the family line of these horses started showing up far from its starting point. This kind of spread can happen when humans carry animals with them, trade them, breed them, or prefer certain traits. Useful animals are moved, strong animals are kept. Calmer or more manageable animals may be bred more often. Over generations, those human choices can change which lineages survive. The horses from this expanding population may have had traits that made them especially useful to people. Some genetic studies have pointed to changes linked with the spine, strength, behavior, or endurance. Those details are still carefully studied because a gene does not act like a simple switch. A body is shaped by many genes, the environment, training, and human selection working together. Even so, the larger pattern is clear. A certain horse population became unusually successful at the exact time when horses were becoming more important to human movement. The date matters. Around 2200 BCE, many Bronze Age societies were changing. People were moving across steppe corridors. Trade routes were growing. Wheeled vehicles, herding economies, metal tools, and long-distance contact were becoming more important in different regions. A horse that could be managed, bred, moved, and used across open land would have been more than an animal. It would have been a new source of reach. Imagine a herd on the western steppe at dusk. The grass is short. The rivers lie low across the land. People know the animals by sight, by age, by strength, by temperament. A foal born there might carry genes that, many generations later, would be found in horses far away. The spread was biological because horse lineages moved and multiplied. It was also human because people gave that movement direction. This is where the horse story begins to enter history at a larger scale. A small forest browser had become a grazing runner. A grazing runner had become a managed animal. Now one lineage was beginning to move through the human world with unusual force. As these horses spread, they changed the meaning of distance itself. A valley, a river, a neighboring settlement, a far grazing ground, all could be reached in a different way once horse movement became part of human life. Across open country, the human body has a natural limit. A person walking with light supplies might cover 15 to 25 miles in a long day, depending on weather, terrain, health, and the weight being carried. With heavier loads, the range becomes smaller. A river valley, a grazing area, or a neighboring settlement could be close enough to know about, yet far enough to require planning, food, daylight, and energy. For most of human history, distance was measured through the body. Feet on ground, weight on shoulders, hours of light, the slow tiredness that gathers in the legs after a long walk. The horse changed that scale. A horse can walk at around 3 to 4 miles per hour for steady travel. It can trot faster, across open land with rest, water, and proper care. A ridden or pack horse can carry a person, supplies, tools, or messages far beyond what a walking person could manage with the same ease. The exact distance depends on the animal, the ground, the load, and the season. Still, the effect was clear. A person with a horse could reach farther. A family with horses could move more. A herder with horses could watch animals across wider pasture. A messenger with horses could cross the space between communities with new speed. This was the range multiplier effect. The horse expanded the area that humans could use in a day, a season, and a lifetime. On the steppe, that mattered deeply. The Eurasian steppe stretches across thousands of miles, from Eastern Europe through Central Asia. Much of it is open grassland, with wide skies, cold winters, dry winds, and scattered water sources. For people living with herds, movement was part of survival. Animals needed grazing. Families needed to follow seasonal pasture. Water, shelter, and trade routes mattered across large spaces. A horse gave people a better way to live within that moving landscape. It could carry a rider toward a distant herd. It could help transport tools and belongings. It could make a far camp reachable before darkness. This kind of mobility also changed how people met one another. Goods could travel farther. Metal tools, ornaments, woven materials, and food products could move between groups. Ideas traveled too, carried by people who could now cross larger areas with less delay. Words, stories, skills, and customs followed routes opened by animals, wheels, rivers, and human memory. The horse did not act alone in this change. Wheeled vehicles had already appeared before the great spread of modern domestic horses. Early wheels are known from the late 4th millennium BCE, long before cars, rails, or engines. A wheel could reduce friction and help move heavy loads across suitable ground. Yet wheels need power. They need something to pull them. Oxen could pull heavy loads slowly. Donkeys could carry packs across difficult ground. Horses brought a different balance of speed, strength, and reach. When harnessed, packed, or ridden, they gave people another way to connect movement with work. A horse could carry a person directly. It could pull a light vehicle. It could move a load across grassland, where a human back would tire quickly. Each use changed the shape of daily possibility. A settlement no longer stood only within walking distance of its closest neighbors. A grazing route could stretch farther. A message could arrive sooner. A tool made in one place could be traded in another place beyond the old edge of ordinary travel. Even time began to feel different. A place that once took several days to reach might become part of a more familiar route. A distant group could become a trading partner. A seasonal camp could be visited more reliably. The horse made distance more flexible. It folded far ground into human life. This is why domesticated horses mattered in a way that was different from many other animals. Sheep gave wool. Cattle gave milk, meat, hides, and pulling strength. Goats could live in rough country. The horse gave motion a new reach. Across open land, that reach changed how people organized families, herds, trade, messages, and power. Once humans began joining horse strength to wheels, the quiet speed of the animal became something more visible. A crafted technology of wood, leather, training, and control, rolling across the ancient ground. Across dry ground, horse speed became easier to see. A pair of trained horses could pull a light vehicle forward, while narrow wheels turned behind them and dust lifted from the path. Leather reins ran from the driver's hands to the horses' mouths. Wooden parts creaked softly under strain. The whole machine depended on timing, balance, and control. The chariot became one of the first great technologies built around horsepower. Bronze Age chariots began appearing around the 2nd millennium BCE, roughly 4,000 years ago. Some of the earliest known examples are linked to the Sintashta culture of the steppe, east of the Ural Mountains. In graves from that region, archaeologists have found traces of light vehicles with spoked wheels, along with horse remains and cheek pieces used in harnessing. A spoke is one of the thin bars connecting the center of a wheel to its outer rim. Spoked wheels made chariots much lighter than older solid wheels. That lighter design mattered. A heavy cart could move goods slowly. A light chariot could turn speed into display, ceremony, hunting, travel, and command. Every part had to work with the rest. The horses needed training so they could move together as a team. A driver needed steady hands and a strong sense of rhythm. A wheelwright had to shape wheels that were light enough to move quickly and strong enough to survive rough ground. A harness maker had to fit leather, wood, and sometimes metal into a system that guided the animals without wasting their strength. The chariot was animal power joined to human craft. The horse supplied motion. The vehicle gave that motion shape. The people around it supplied planning, care, and skill. Because of this, chariots were never only a matter of having horses. They required an organized world behind them. Someone had to breed or acquire suitable animals. Someone had to feed and train them. Someone had to repair wheels, replace worn leather, store spare parts, and prepare level ground where the vehicle could move well. A chariot worked best in open terrain, dry plains, prepared roads, or broad fields. Deep mud, thick forest, steep hills, and broken stone could turn its speed into difficulty. This made geography important. A chariot belonged most naturally to places where land, roads, and open space allowed the wheels to run. Over time, chariots appeared in many ancient societies. They were used in parts of the Near East. They entered Egypt, where horses and chariots became closely tied to royal power. They spread through steppe cultures and into parts of Asia. In ancient art, chariots often appear beside kings, nobles, hunters, and high-status warriors. They were drawn on walls, carved into reliefs, buried with elites, and described in old texts. The image itself carried meaning. A person standing in a chariot was raised above the ground. The horses in front showed wealth and training. The wheels showed advanced craft. The whole scene told people that power could move quickly. Even when chariots were used in conflict, their meaning reached beyond battle. They appeared in ceremonies. They carried rulers. They were used in processions and hunts. They showed that a society could organize animals, materials, roads, workers, and skill around one moving object. A chariot was a public sign that horses had become part of human hierarchy. The quiet grazing animal had entered the world of courts, temples, armies, and carved stone monuments. Still, the chariot had limits. It needed a vehicle. It needed suitable ground. It needed space for wheels to turn. The horse's body could do more than the chariot allowed. A horse could cross narrow paths, climb gentler slopes, follow herds, pass through uneven country, and move without dragging wood behind it. As people learned to ride more effectively, horse mobility became more direct. The wheel had made speed visible and organized. A person on the horse's back could carry that speed into places where a chariot could never go. Mounted travel brought the person closer to the animal's own movement. Instead of standing behind a pair of horses and guiding a vehicle, the rider sat directly above the horse's back. The motion came up through the animal's spine, shoulders, and hips. Each step moved the rider too. To stay balanced, the human body had to learn the horse's rhythm. A walking horse moves with a steady 4-beat pattern. A trot has a 2-beat rhythm, with opposite legs moving together. A canter rolls forward in 3 beats. A gallop stretches into a faster, longer motion, where the horse's body gathers and extends with each stride. Riding depends on much more than sitting still. A rider uses weight, hands, legs, voice, and timing. Reins connect the hands to the bridle. Pressure from the legs can ask the horse to move forward or shift direction. Small changes in balance can help guide turns or slow the pace. The horse learns these signals through repetition. The person learns how much pressure is needed, when to release it, and how to stay calm while the animal responds. This made riding a living form of communication. The message did not travel through wheels or wooden shafts. It passed through muscle, leather, breath, and movement. Studying early riding is difficult because leather, rope, and wood often decay. A saddle or bridle from thousands of years ago may leave little behind. So archaeologists search for quieter signs. A bit placed in a horse's mouth can sometimes leave wear marks on the lower premolars, the teeth near the front of the cheek tooth row. Those marks need careful interpretation because teeth can wear for different reasons. Human skeletons can also preserve clues. People who rode often may show stress changes in the pelvis, thigh bones, or spine. Some Bronze Age skeletons from step graves around 3000 BCE have been studied for patterns linked to repeated riding. These clues do not always prove a single person was a rider, but together they help reveal when horseback life began to leave marks on bodies. The equipment improved over time. Early riders may have used simple pads, blankets, or bareback methods. Later, saddles spread the rider's weight more comfortably across the horse's back. Stirrups came later still. A stirrup is a loop or frame that supports the rider's foot. Once stirrups became common in different regions, they improved stability, mounting, and control, especially during long travel or difficult movement. Yet people were riding horses long before the full saddle and stirrup systems became standard. The first riders worked with fewer tools and a much more direct feel for the animal beneath them. On the steppe, that direct mobility changed daily life. Mounted pastoralists could watch over sheep, goats, cattle, and horse herds spread across large grazing areas. Pastoralists are people whose lives are built around herding animals. In wide grassland, animals must move to fresh pasture and water. A person on foot can only cover so much ground. A person on horseback can check distant animals, follow a moving herd, carry messages between camps, and return before the weather or daylight changes. Riding also made scouting easier. A rider could climb a rise, look across miles of open land, and move towards smoke, tracks, water, or grazing animals. Across plains, river valleys, and seasonal routes, the horse and rider became a single traveling unit. This was more flexible than a chariot. A chariot needed space for wheels. A mounted horse could follow narrower paths, cross uneven ground, and move with fewer materials. The rider did not need a wheelwright nearby. The horse did not need a prepared road to the same degree. The bond was still practical, shaped by training and need, but it brought the human body into the horse's own line of motion. A person could now move with the animal rather than behind it. That closeness changed how people crossed land. It changed how herds were managed. It changed how settlements stayed connected across distance. Once riders could move quickly and fresh horses could be placed along routes, the horse became part of something larger than travel. It became a living network for carrying words, orders, warnings, and news across the ancient world. Across those long routes, a rider could become more than a traveler. A rider could become the moving edge of a message. Picture a sealed order leaving a city gate at dawn. The rider carries it out past fields, river crossings, watch posts, and low hills. The horse beneath him does not need to finish the whole journey. That was the secret of the relay. A relay system works by dividing distance into smaller pieces. One horse carries the rider or message for part of the route. At a station, a fresh horse is waiting. The rider changes mounts, or the message passes to another rider, and the movement continues. This made communication faster because exhaustion was spread across many animals instead of placed on one. A single horse needs rest, water, food, and recovery. A line of prepared horses can keep a message moving across country with far less delay. One of the most famous ancient examples was the Persian Royal Road. It linked important parts of the Achaemenid Empire, which ruled from the 500s to the 300s BCE. The road is often described as running between Susa, in what is now Iran, and Sardis, in western Anatolia, in what is now Turkey. That route stretched roughly 1,500 miles. Along the way were stations where official travelers could find fresh horses, supplies, and shelter. This was more than a road across land. It was an organized system of distance. The Greek historian Herodotus wrote with admiration about Persian messengers and how reliably they carried messages through difficult weather and long routes. His famous description later inspired the wording linked with modern postal service ideals. The point was simple and powerful. A ruler in one place could send words across an empire and expect them to arrive. That changed how large territories could be governed. Orders, reports, warnings, tax information, military news, and royal decisions could move through the landscape faster than an ordinary traveler walking from town to town. The horse became part of administration. It helped turn distant places into connected places. Centuries later, the Mongol Empire built one of history's largest relay networks. It was called the Yam. Across the 1200s and 1300s, Mongol rulers controlled routes that stretched across much of Eurasia. Their relay stations held horses, food, and lodging for official messengers. A messenger carrying a tablet of authority could receive fresh mounts and support along the way. Some stations were spaced by a day's ride, though spacing changed with terrain, water, and local needs. On open steppe, the system could move information with remarkable speed. This mattered because the Mongol Empire covered enormous distances. No single rider could manage such a world alone. The network made the scale possible. Roads, tracks, river crossings, grazing land, wells, barns, handlers, and record keepers worked around the horse. A message moving across the Yam was really moving through a living machine made of animals and people. The horse supplied the motion. The stations supplied renewal. The administration supplied direction. Other societies built their own horse-based communication systems as well. Imperial roads, royal couriers, military messengers, and later postal riders all depended on the same basic principle. Fresh animals placed along a route can make distance behave differently. A message that might crawl across the land at walking speed could instead pass from horse to horse, station to station, and rider to rider. This changed the feeling of a state. A far province became easier to reach. A border report could arrive sooner. A decision made in a capital could travel outward through valleys, plains, and towns. The horse was becoming infrastructure. Infrastructure means the hidden support system that lets a society work. Today, that word often brings to mind roads, wires, ports, pipes, and rails. For much of history, infrastructure had hooves, lungs, stables, leather straps, and piles of stored feed. A government that wanted fast messages needed more than horses. It needed people who bred them, trained them, fed them, and replaced them when they tired. It needed routes that could be followed in dry seasons and wet seasons. It needed water points. It needed trust that the next station would be ready. The animal in the field had become part of a system larger than any single rider. Horses carried words between rulers, but their work did not stay in royal service. The same strength that moved messages across empires also entered ordinary life through fields, wagons, markets, and town streets. A village morning gives that strength a different shape. Instead of a royal courier changing mounts at a station, there is a horse standing beside a wooden cart. Leather harness rests across its chest and shoulders. A farmer checks the straps by hand. A wheel settles into a rut. Beyond the yard, a field waits for the first slow line of the plough. For centuries, horses served as everyday engines. Their bodies turned grass, hay, oats, and water into pulling power. A draft horse could lean into a load with its chest lowered, hooves pressing into soil, muscles working through the shoulders and hindquarters. The word draft means pulling. Draft horses were bred for strength, calmness, and heavy work. They pulled ploughs through fields, dragged wagons along roads, turned mills, moved timber, hauled coal, and carried goods into towns. This work was practical and constant. A farm horse might help prepare soil in spring, pull hay wagons in summer, carry crops in autumn, and haul firewood in winter. In many places, horses worked beside oxen. An ox is usually a trained cattle animal used for pulling. Oxen were strong, patient, and often cheaper to feed because cattle could live on rougher forage. They were useful for heavy, slow work. Horses could often move faster and cover more ground in a day, especially when roads improved and good feed was available. That speed made them valuable for hauling goods, traveling to market, and doing farm tasks where time mattered. The choice between horse and ox depended on money, land, feed, climate, and local custom. A horse needed care. It needed pasture when possible. It needed hay when grass was unavailable. A working horse often needed oats or other grain for extra energy. It needed clean water, shelter, and attention to the feet. The hoof that evolved for open country now had to meet stone roads, wet fields, frozen ground, and hard-packed town streets. Farriers became essential. A farrier is a trained worker who trims hooves and, when needed, fits metal shoes. Horseshoes helped protect hooves from heavy wear, especially when animals worked on roads or pulled loads for many hours. Harness design also changed how much work a horse could do. A poor harness can press against the windpipe and make pulling difficult. Early throat and girth systems could limit the use of a horse's full strength because pressure near the neck could interfere with breathing. The padded horse collar solved much of this problem. It spread the load across the shoulders and chest, where the animal could push forward more safely and powerfully. Versions of the horse collar were used in Asia before spreading widely in medieval Europe. By the Middle Ages, improved collars helped horses become more useful in heavy farm work, especially when paired with better ploughs and field systems. This was a technology as real as a wheel or a road. It was soft material shaped to fit a living body. A small change in where pressure rested could change how much land could be worked. Horse labor created a whole economy around itself. Someone had to grow hay. Someone had to harvest oats. Someone had to repair wagons, make wheels, tan leather, build stables, clean stalls, and care for tired animals at the end of the day. Blacksmiths shaped iron. Farriers watched hooves. Stable hands measured feed and brushed sweat from coats after work. Harness makers stitched straps strong enough to hold under strain. In mining districts, horses and ponies pulled carts of coal or ore. In forests, teams dragged logs from cut land toward rivers or roads. In towns, horses moved barrels, bricks, flour, milk, furniture, and mail. The animal that once survived by grazing and watching the horizon became part of human labor at nearly every level. A horse could carry a message for an empire. It could also pull a family's harvest from a field. Both depended on the same living engine: breath, muscle, hooves, food, training, and human care. As more of this work gathered inside growing towns, the streets began to carry the marks of horsepower everywhere. Road surfaces, stable doors, feed stores, watering troughs, and daily traffic all formed around the needs of animals moving through human-built space. Inside the growing city, horsepower became crowded. A 19th century street could be filled from morning until night with hooves, wheels, voices, bells, and wooden shafts. Carriages carried families and officials. Omnibuses moved groups of passengers along fixed routes. Freight carts brought coal, flour, bricks, beer barrels, furniture, ice, and vegetables through narrow streets. Fire wagons stood ready, with teams of strong horses trained to respond quickly when alarms rang. Before electric streetcars became common, many city streetcars were pulled along rails by horses. The rails helped reduce friction, so one or two horses could pull more passengers than they could on ordinary road surfaces. For a city, this was a major improvement. People could travel farther to work, shop, visit, and return home. Businesses could move goods through streets more regularly. A city could grow wider because horses helped connect its parts. Yet every hoof-powered system had a living cost. A horse is a body, not a machine. It eats every day. It drinks every day. It needs rest, shelter, grooming, hoof care, and space to stand. In a large city, thousands of working horses meant thousands of daily needs moving through the streets at the same time. A single working horse might eat many pounds of hay and grain in a day. That feed had to be grown outside the city, hauled inward by wagon or rail, stored in barns and feed shops, then carried to stables. Oats, hay, straw bedding, and clean water were part of the hidden supply chain behind every carriage ride and delivery cart. Water mattered especially during long working days. Cities needed troughs, pumps, wells, and stable yards where animals could drink. The waste was even harder to ignore. A horse can produce well over 20 pounds of manure in a day. In a city with tens of thousands of horses, that became an enormous daily burden. Manure gathered in streets, stable yards, alleys, and vacant lots. It had to be shoveled, carted away, sold as fertilizer when possible, or dumped outside dense areas. In warm weather, it attracted flies. After rain, it mixed with mud. In dry weather, it could break into dust and blow through the street air. This was one of the great urban problems before engines. The horse gave the city movement, and the city had to manage the biology that came with it. Stables became as important as garages would be later. Some were small private carriage houses behind homes. Others were large commercial buildings holding many working animals. Inside them were stalls, feed bins, harness racks, bedding, buckets, and tools. Stable workers cleaned, fed, brushed, watered, and watched the horses. Blacksmiths and farriers worked nearby, shaping shoes and caring for hooves worn by stone, brick, and packed road. Carriage makers repaired wheels, axles, springs, and shafts. Harness makers stitched leather that had to hold under daily strain. The whole city carried a horse economy within it. There were also risks. Crowded streets could frighten animals. A sudden noise, a loose strap, a slipping wheel, or a blocked road could turn ordinary movement into danger. Horses could fall on icy streets. They could strain muscles while pulling heavy loads. They could become exhausted from overwork. City traffic was a mix of animal strength and human urgency, all moving through shared space. Even the soundscape belonged to horses. Iron shoes struck stone. Wagon wheels rattled. Drivers called out. Stable doors opened before dawn. The city woke with animal labor already in motion. For a time, horse-powered cities were a great achievement. They moved people, goods, water, food, mail, and emergency help at a scale earlier towns could not match. The same system also pressed against its limits more each year. As populations grew, streets became busier. As businesses expanded, deliveries multiplied. As cities stretched outward, people needed faster and cleaner ways to move. The horse had carried urban life as far as biology allowed. Then engines began to enter the street, offering movement without hay wagons, stable rows, daily manure, or tired animals waiting at the curb. Engines entered slowly at first. A rail line appeared across land where horses had once pulled wagons from town to town. A steam locomotive could carry people, coal, timber, grain, and mail over long distances without stopping at every stable yard. The first public steam railways grew in the early 1800s, and by the late 19th century, railroads had changed the movement of whole countries. A horse team could pull a wagon along a road. A locomotive could pull many loaded cars along iron rails. The difference was more than speed. It was scale. Freight that once needed teams, drivers, feed, rest stops, and road conditions could now move in long chains behind one engine. Horses still brought goods to stations. They still worked in towns and farms. But the longest journeys were beginning to shift away from hooves. Then engines moved into the street. By the early 1900s, automobiles and trucks were becoming more common in cities that had once depended on carriage horses, delivery horses, and horse-drawn streetcars. Electric streetcars replaced many horse-drawn lines. Motor trucks began taking over freight routes inside towns. Fire departments changed too. For generations, trained fire horses had pulled heavy wagons toward alarms. As motorized fire engines spread, the old stable doors opened less often. A truck could sit ready without needing hay, bedding, grooming, or a night of rest after hard work. It still needed fuel, repairs, and trained operators. But its care belonged to a different world. The farm changed more slowly, then very deeply. In the late 1800s and early 1900s, Many farms still depended on horses for ploughing, harrowing, planting, mowing, hauling hay, and taking crops to market. A good farm team was valuable because it could work through soil, pull wagons, and respond to a farmer's voice and hands. Then, tractors began to spread. Early tractors were heavy and expensive, but by the 1920s and 1930s, improved models became more practical. After World War II, tractor use expanded even faster in many industrial countries. A tractor could pull equipment for long hours. It could work with machines that cut, planted, lifted, and hauled in ways animal teams could not easily match. It used fuel instead of oats. It could be stored in a shed instead of a stable. Its power did not depend on pasture or breeding. This was technological substitution. That means one system replaces another, because it can do the same job with different costs, greater force, or easier control. For thousands of years, the horse had been one of the main ways humans turned plant energy into movement. Grass became muscle. Oats became pulling power. Hay became a wagon load moving down a road. Engines changed the chain. Coal, oil, gasoline, diesel, steel, rubber, and electricity began doing work that once passed through living bodies. The change was practical, but it touched a very old relationship. In many industrial countries, horse populations declined sharply during the 20th century. The United States had more than 20 million horses and mules in the early 1900s. By the middle of the century, the number had fallen by many millions as tractors, cars, and trucks took over common jobs. Draft breeds felt this change strongly. Large working horses such as Clydesdales, Shires, Percherons, and Belgians had been bred for strength, weight, and calm pulling power. When heavy farm and freight work disappeared, fewer people needed to breed or keep so many of them. Some survived through dedicated breeders, shows, logging work, farms that kept traditional methods, and public affection for their size and beauty. The old working world did not vanish in one day. For a while, horses and machines shared roads and fields. A cart might pass a motor car. A tractor might work one farm while horses worked another nearby. A city might still smell of stables, while gasoline engines grew louder along the same streets. Gradually, the balance shifted. The horse that had carried messages, pulled plows, moved families, powered cities, and helped build the modern world, became less central to daily survival. Its work changed. Its place changed. Yet the animal remained. People kept returning to barns, pastures, riding paths, racetracks, and quiet fence lines, drawn by something deeper than the old need for transport or labor. The old work faded, but the relationship did not fade with it. Barns still filled with the sound of hooves on packed earth. Pastures still held horses standing nose to tail in the afternoon light. Riders still brushed dust from coats, cleaned hooves with small metal picks, and checked leather straps before opening a gate. The horse was no longer needed in the same way by most people. Its place had changed from daily labor to chosen care. That change made the bond quieter, but in some ways more visible. When a horse is kept for riding, sport, therapy, ranch work, or simple companionship, the relationship depends less on force and more on communication. A person cannot explain a plan to a horse with words. The message has to pass through posture, timing, pressure, release, and repetition. The horse notices how a person stands. It notices whether the body is tense or loose. It notices where the eyes are looking, how the hands move, and whether a person approaches quickly or calmly. This sensitivity comes from the horse's long history as a prey animal. A prey animal survives by reading small changes early. Sudden movement can mean danger. A sharp sound can make the body prepare to flee. An unclear signal can create confusion. For a horse, attention is practical. It is part of staying alive. Studies of horse behavior show that horses can respond to human facial expressions. They can tell differences between relaxed and angry faces. They also use body posture, direction of attention, and familiar handling patterns when deciding how to respond. Some research suggests that horses may even react to human body odors linked with emotion, such as fear or calm. A horse lives in a world where scent, movement, muscle tone, and spacing all matter. Human communication reaches it through all of those channels at once. This is why consistency becomes so important. A horse learns from repeated patterns. If a person gives the same cue in the same way, then rewards the right response by softening the pressure, the horse can begin to understand. Pressure and release is a common idea in horse training. Pressure might mean a light pull on the rein, a touch from the rider's leg, or a gentle request from a lead rope. Release means the pressure stops as soon as the horse gives the desired response. The stopping is the message. It tells the horse, yes, that was the answer. Over time, a large animal weighing 900 to 1,200 pounds can learn to respond to very small signals. A shift of weight in the saddle, a softening of the hand, a step toward the shoulder, a quiet voice paired with a familiar routine. The training works best when the person is clear and patient. Poor timing can make the horse unsure. Mixed signals can make a calm animal resistant or worried. Rough handling can teach fear instead of trust. Because horses remember repeated experiences, trust forms slowly through predictable care. A horse that is led gently, fed regularly, groomed calmly, and handled with steady signals can begin to see a person as safe. This does not erase the animal's nature. A horse remains watchful. Its ears still turn toward distant sounds. Its body still prepares for sudden movement. But familiarity changes how it reads the human beside it. The bond becomes a learned pattern between two very different species. One is a primate with hands, language, and forward-facing eyes. The other is a grazing herd animal with wide vision, quick feet, and a deep need for safety. Meeting in the middle takes practice. That may be part of why horses still hold people so strongly. They ask for attention that cannot be rushed. They reward calm behavior in ways that feel immediate. A nervous person can feel the horse grow uncertain. A steady person may feel the animal settle. The relationship becomes a kind of mirror, built from breathing, touch, posture, and memory. After machines took over so much of the old labor, horses remained because they offered something engines could not offer. They were living partners with their own fears, habits, preferences, and trust. To stand beside a horse is to be read by another animal in real time. To understand that feeling more fully, it helps to enter the horse's own sensory world, where small movements, soft sounds, and quiet changes carry meaning long before a human notices them. A horse may lift its head before the person beside it hears anything. The sound might be small, a branch rubbing against a fence, a bird moving in dry grass, a jacket sleeve shifting in the wind. To a human, the field may seem quiet. To a horse, the same field is full of tiny changes arriving through sight, sound, smell, touch, and pressure. A horse's eyes sit on the sides of its head. This gives it a very wide field of view, often described as close to 350 degrees. That wide view helps a grazing animal watch much of the world while its head is lowered. Movement can appear from the side long before it reaches the body. A shadow crossing the edge of the field can matter. A shape appearing near the fence can matter. A person walking up from an unexpected angle can matter too. The wide view also has limits. A horse has a blind spot directly in front of its face, close to the nose. It also has a blind spot directly behind the body. This helps explain why careful handlers approach from the side, speak softly, and avoid sudden movement near the hind legs. The horse may not clearly see what is happening in those hidden zones. A gentle voice or a hand placed where the horse can feel, it helps turn surprise into information. The ears are just as expressive. Each ear can move on its own, turning toward different sounds. A horse can listen forward and backward at nearly the same time. The ear muscles make small adjustments, pointing toward a gate latch, a person's step, another horse, or a distant engine. This is why ears often show attention before the rest of the body moves. A horse standing still may already be tracking several things at once. Its face, neck, and shoulders can remain quiet, while the ears keep reading the air. Smell adds another layer. Horses use scent to recognize other horses, investigate unfamiliar objects, and gather information from their surroundings. A horse may lower its nose to a new bucket, a patch of ground, a person's hand, or a blanket that carries another animal's scent. At close range, the muzzle becomes especially important. The long whiskers around the lips and nose are called vibrissae. They help the horse sense nearby objects that may be hard to see clearly because of the blind spot in front of the face. When a horse explores a feed bin, a hand, a fence rail, or the edge of a water trough, those whiskers help map the space just in front of the mouth. Touch matters across the whole body. A horse can feel a fly landing on its skin and twitch one small patch of muscle to move it away. That same sensitive skin also feels the brush of a grooming tool, the weight of a saddle pad, and the pressure of a rider's leg. In riding and groundwork, pressure becomes language. A light pull on a lead rope can ask the horse to step forward. A shift of weight can ask for balance. A gentle touch near the side can ask the body to move away. The horse learns what these signals mean through repetition and release. Its nervous system is built for early warning. In open country, quick reaction helped keep ancient horses alive. A sudden sound or fast movement could mean a predator was close enough to matter. Modern horses still carry that body history. A plastic bag fluttering beside a trail may look harmless to a person, but to the horse it appears first as movement without a clear meaning. The body prepares before the animal has time to investigate. The head rises, the muscles tighten, the feet may shift, ready to turn or move away. Calm handling gives the horse a way to sort the signal. A steady voice, slow breathing, familiar routines, and clear body language can reduce confusion. Predictability tells the horse that the person nearby is safe to read. Over time, the animal learns that some human movements have meaning and others can be ignored. The partnership grows through this quiet sorting of signals. A person brings forward-facing eyes, planning, words, and hands. A horse brings wide vision, moving ears, sensitive skin, scent, memory, and fast attention. The bond happens where those two systems meet. That is part of why horses have gathered so much meaning around them. An animal that notices so carefully can feel powerful, delicate, ancient, and deeply present all at once. Across history, people began filling that presence with ideas of freedom, strength, memory, beauty, and trust. That meaning still follows horses into the modern world. They appear in places far removed from ancient grasslands and relay roads. A thoroughbred breaks from a starting gate on a racetrack. A small pony waits beside a fence at a riding school. A draft horse steps slowly through a parade, its feathered lower legs moving above the pavement. A quiet therapy horse stands beside a person who is learning how to breathe steadily again. The old jobs changed, yet horses kept finding new places in human life. Part of that comes from breeding. For thousands of years, people chose certain horses to produce the next generation. They selected for size, speed, strength, color, gait, endurance, and temperament. Temperament means the usual pattern of an animal's behavior, such as calmness, alertness, boldness, or sensitivity. Over time, those choices shape different kinds of horses for different human needs. The thoroughbred is one of the clearest examples. This breed developed in England during the 1600s and 1700s, when local mares were crossed with imported stallions of Arabian, Barb, and Turkoman ancestry. Thoroughbreds were shaped for racing speed. Their bodies are usually lean, deep-chested, and long-legged, built for fast work over a track. A racehorse can reach speeds around 40 miles per hour for short stretches, though the exact speed depends on the horse, the distance, and the conditions. The Arabian carries a different history. Arabian horses are linked with desert regions of the Middle East, where endurance, sure feet, and close human care mattered deeply. They are known for stamina over long distances. Their faces often have a dished profile with a slight inward curve. Their tails are often carried high. In endurance riding today, Arabian bloodlines remain important because these horses can travel many miles with careful pacing and conditioning. Draft breeds show another path of selection. Clydesdales, Shires, Percherons, and Belgians were shaped for pulling power. Many stand taller and heavier than riding breeds. A large draft horse can weigh well over 1,500 pounds. Its broad chest, strong hindquarters, and calm nature made it valuable for farm work, hauling, logging, and heavy wagons. Even after tractors reduced the need for draft teams, these horses remained in shows, historic farms, parades, and specialized work. Ponies carry their own kind of usefulness. A pony is generally under 14.2 hands high at the withers A hand is 4 inches. The withers are the high ridge between the shoulder blades. Many pony breeds are hardy, meaning they can do well in rough weather, sparse grazing, and difficult ground. Shetland ponies, for example, come from the Shetland Islands north of Scotland, where small size and toughness helped them survive cold winds and limited pasture. Selective breeding also shaped horses that move in special ways. Some breeds have smooth extra gaits, which are footfall patterns beyond the common walk, trot, canter, and gallop. The Tennessee walking horse is known for a smooth running walk. Icelandic horses can perform the tolt, a steady gait that can feel easier for a rider over distance. These movements show how deeply humans noticed comfort, rhythm, and use. Modern horses now live in many roles at once. They race, they jump, they perform careful movements in dressage, where a horse and rider complete precise patterns from subtle cues. They still work on ranches, helping move cattle across land where vehicles may be less useful. Mounted police use horses in some cities because a rider sits high, moves through crowds, and can be seen from far away. Therapy programs use horses in carefully managed settings where grooming, leading, riding, or simply standing near the animal can help people practice balance, attention, confidence, and calm contact. Horses also remain in stories. They appear in films, myths, statues, paintings, flags, children's books, and national symbols. Pegasus, the winged horse of Greek myth, carried the idea of movement into the sky. The white horse has appeared in legends, royal images, and ceremony. Wild horses on open land often stand for freedom, even when their real lives are shaped by weather, food, herd pressure, and human management. This is cultural persistence. When an animal becomes tied to work, travel, memory, and identity for thousands of years, it can keep its meaning after its original job changes. A horse in a quiet field can still suggest motion. A horse beside a person can still suggest trust. A hoofprint in mud can still feel older than the road beside it. Now the story can gather what the horse has carried across time. Bodies, messages, harvests, cities, distance, and the soft human feeling that remained after the engines arrived. All of that history returns to the quiet animal in the field. A horse stands with one hind leg resting, its ears turned toward small sounds. Its muzzle lowers toward the grass. From the outside, the scene is simple. Yet the body standing there carries a story that began around 55 million years ago. The earliest horse relatives were small forest browsers. They moved through warm, ancient North America on several toes. Their low-crowned teeth were suited to soft leaves, fruit, and tender plants. They were close to the ground, moving through shade, roots, damp soil, and branches. Over millions of years, the world around them changed. Forests thinned in many places. Open habitats spread. Grass became more important. That new food was rougher on teeth because grass contains silica and often carries tiny grains of grit from the soil. Horse teeth became taller, with more material to wear through. Their jaws became better at grinding. Their bodies stretched into longer shapes. Their legs grew more useful for open ground. Several toes slowly gave way to one main weight-bearing toe. That toe became the modern hoof. Every hoofprint still holds that old change inside it. A horse walking through mud is using an ancient middle toe, strengthened by deep time. Its long limbs, springing tendons, wide vision, moving ears, and herd awareness all belong to the same survival story. A grazing animal on open land needs food, movement, and attention. It needs to chew for many hours. It needs to notice danger early. It needs other horses nearby, sharing rest, warning, and calm. The horse family began in North America, then moved outward. During colder periods, lower sea levels exposed land routes such as Beringia, the broad region that once connected Alaska and Siberia. Horse populations crossed into Eurasia over many generations. Then, near the end of the last ice age, roughly 10,000 years ago, horses disappeared from North America. The continent where they had evolved became a place without them. They survived elsewhere, and much later, European ships brought domestic horses back across the Atlantic. Human history had already changed them by then. Before partnership, people hunted horses, used their meat and hides, shaped tools from bone, and painted their bodies on cave walls. At Chauvet Cave in France, horse images more than 30,000 years old still hold the memory of Ice Age attention. At Lascaux, around 17,000 to 20,000 years old, horses appear again among the great painted animals. People knew their shape before they ever guided their movement. Around 5,500 years ago, the Botai culture of northern Kazakhstan left some of the earliest strong evidence of horse management. Their sites contain many horse bones, possible signs of enclosures, debated tooth wear, and pottery residues interpreted as mare's milk. That story is important, though most modern domestic horses seem to come mainly from another lineage. Around 4,200 years ago, horses from the western Eurasian steppe, especially near the lower Volga and Don rivers, began spreading widely. With that spread, distance changed. Horses carried riders across open country. They pulled light chariots with spoked wheels. They helped herders manage animals across wide pasture. They moved messages through relay stations, where fresh horses kept words traveling across empires. They pulled plows through fields, wagons through villages, and carts through crowded city streets. They helped shape farming, trade, communication, conflict, travel, ceremony, sport, and memory. For thousands of years, human movement often depended on breath, muscle, hoof, harness, hay, oats, water, and care. Then machines arrived. Railroads moved heavy loads across long distances. Cars and trucks entered streets. Tractors replaced many farm teams. Engines changed the old chain of work. Coal, fuel, steel, and electricity began doing jobs that horses had done with living bodies. Many working horses were no longer needed in the same way. Still, the bond remained. People kept brushing coats, cleaning hooves, riding trails, opening stable doors, and standing quietly beside warm, breathing animals. The horse stayed because its meaning had grown larger than labor. It had become part of how humans pictured movement, trust, patience, power, and freedom. A horse standing in a field carries the ancient forest, the grassland, the steppe, the road, the farm, the city, and the person beside it. All of those histories rest together in one living body. The head lowers, the ears soften, the field grows quiet again, and the long story of horses settles back into the simple sound of breathing in the dark.